Could somebody please confirm you can hear me?
Can hear you.
Great, thank you. Oop, wrong one. All right, let me share my screen. I can find it. It's not showing up right. Oh, that's been a trouble. All right, got it now. Be seeing my screen. Of course, there's not much to see here, but
Yes.
all right, there we go. Um, are there any questions before we begin? If not, let me state that today is October 7th, and we should be starting Lab 3, Microscope Basics. Let me state, I haven't got Lab 2 graded. I'm going to try and get that graded tonight, maybe early this morning. And Lab 2 will be graded for at least 2 times. The remaining labs will be graded depending on how you vote for it or how you voted for it, meaning it's already closed. I reopened it, but I'm not going to take anybody's comments on that. If you commented earlier, I will take your vote. I haven't looked to see how the class voted, but I imagine the class voted to have the labs graded 2 times. Anyways, lab 2 will be graded 2 times, and if I get it graded by Wednesday morning, I will then do the second grading this Saturday, which is set up for this time. So the first grading will be the due date, and the until date will be for the second grading. Any question about any of that? The reason why I do it that way is Canvas is not set up to have an assignment graded 2 times, so I use the due date for the first grading and then the until date for the second grading. And let me remind you that I will try and get the first grading of the labs graded within a week of when you submit it. But the second grading, I'm not going to make any promises because my priority will be doing the first grading. And so, good, the lecture file just finished making. So the first grading of Lab 2 is now, and that means the second grading of Lab 2, I probably won't get done because I'll be grading the first grading of Lab 3 and 4 after this Saturday. So the second grading is going to be postponed probably until late in the term, and I'll get them graded whenever I have time to get the grading done. Any question about any of that?
I do have a question, Professor. It looks like I don't have a grade for Lab 1 still. Is that true for everyone?
No, they were graded the first time. I haven't graded it the
Okay.
second time. Why would
I
I
have
do
not
them the first time?
received I have not received a grade for Lab 1.
Did you turn the lab in late?
I did not.
I'm not sure why you didn't get graded. Can you remind me after I'm done talking about the lecture? And I
Sure,
will look into why you don't have a grade.
no problem.
Unless I didn't get lab 1 graded. Let me take a look at that. I'm going to stop the share. I'm just going to quickly look at the grade book. I got lab 0 graded. I thought I got lab 1 graded, but maybe I haven't. Come on.
Mine wasn't graded as well.
Yeah, I have a feeling I haven't gotten lab 1 graded yet, but let me take a look. Oops, I'm not finding lab 1. Yeah, I don't have lab 1 graded yet. That's why it's not done. I thought I did it, but I have not. So my priority will be lab 2, and then I'll get to lab 1.
Thank you for the confirmation.
Okay.
I also have a quick question while you're on the subject of grades. The first quiz that we did for the environmental quiz,
Hmm.
did you say you were taking the first one off when if we retested for the second time or retested?
Yeah, I've done the grading for the retest, but I've not transferred the grade over to the environmental quiz.
Okay,
And
thanks.
I also have to make the retest a score out of 0, so it's not going to count in the final points. So I've got to
Oh,
do
okay.
that as well. So anyways,
Okay.
I haven't done that.
Okay, thanks.
All right, let me share my screen, make sure I'm out of the grade book. I'm not, so let's get out of the grade book before I share my screen. I'm really bad about showing you stuff that I shouldn't because I don't realize I'm sharing my screen. And so let me get out of the grade book and then I'll share my screen. And I should say I'm not really bad about it. I'm just an absent-minded professor. And there, now you're not seeing the grade book, so everything's good. All right, let's get to the lab 2. Microscope basics. You need to read this lab module and the class textbook, chapter 3 through the end of the section on compound light microscopy before you do this lab. They're not going to be physically using a microscope, but we're going to go through the lab. You need to know the lab module, and then we will use a virtual microscope, which will give you practice on using a microscope online. Any question about any of that? All right. So locate and name the parts of the compound light microscope along with describing their functions. This is a learning objective. And then 2, calculate the total magnification of each objective used. 3, know the guidelines for focusing on specimens with the different objectives. We have 4 different objective lenses: the scanning objective lens or the 4x lens, the low power lens or the 10x objective, the high power lens or the 40x objective lens, and the oil immersion lens or the 100x objective lens. Let me state, I do not like using the names low power and high power because students frequently get these confused. When they say low power, they're meaning the lowest, and low power is not the lowest. The 4x lens is lower than the 10x lens. And the high powered lens is not the highest because that's the 40x lens. The 100x lens is the highest magnification lens you can use. Any question about any of that? So I'm warning you, if you use these names, that the low power is not the lowest and the high power is not the highest. I always get students confused on that every term, so I'm warning you. Anyways, estimate the size of a specimen when seen using the different magnification powers. And then 5, understand the rules for proper microscope care. You're not going to be truly working with the microscope, but you need how to take care of a microscope because you've taken the class microbiology. And then lastly, define the terms associated with the microscope. The terms in the module and in the textbook. All right, you need to memorize the names and the function of these parts of the microscope. 1, all the parts labeled here. 1 is the ocular lens or the eyepiece. 2 is the arm of the microscope, which you carry the microscope from this part here, as well as you'll need to put your hand underneath it. We'll talk about that. 3, that's the stage where you put the slide on. The stage moves up and down for focusing. 4, the stage clip, which holds the slide into place, and it can move the slide this way and that way, as well as this way and that way. How the stage clip moves is with the stage clip controller, and that's 5. One knob moves it this way and that way. One knob moves it that way and that way. And there's the controlling knobs for the stage clip. 6 is the 6 is the iris diaphragm, and that's a lever that opens up the light being shown onto the specimen. You want for color illumination, you want the light to be about the same size as your field of view. We'll talk a little bit about that later. And you need to open up or close down the shutter to give you the correct cone of light size. Generally, when you're starting with the 4X lens, you have the cone of light large, and then as you move up in the objective lens, you start shutting down that cone of light. And you do that by using the iris diaphragm, which is number 6. Number 7 is right here, and let's see if I can get it to move. Nope. I don't know why I can't get that up. I moved the wrong picture. I can't get 7 to move. I couldn't get in the move in the last one either. And I don't know why. I can't get it to move. Yeah, there's no way to move it from this control either. Not sure what the problem is. Anyway, 7 is in the wrong place. It should be with this red arrow there. And that is the condenser. That is a lens that puts a cone of light up on the slide or the specimen here. And like I said, you need to shut that cone of light down to be the appropriate size for your field of view. And how you do that is with the iris diaphragm number 6. So this lens does not magnify, but it gives a cone of light on the specimen. And that's the condenser. 8, I moved this picture a little bit. Let me see if I can move it back. Oh, well, let's go right there. There we go. That's pretty good. 8 is right there. It's not pointing exactly, but the maybe I can move it a little bit further. Kind of. That's the coarse focusing knob. 7 is in the wrong place. Sorry about that. And I don't know why I can't move it. It should move now, but it's not. Unless, maybe that's why I can't move it. Nope, that's the editing in the text. That didn't work. All right. So 8 is the coarse focusing knob. 9, the small one there, is the fine focusing knob. The coarse focusing moves the stage at a fast amount greatly, moving the stage up and down to coarsely focus. 9 moves the stage very slowly in fine gradations, and that's for fine focusing once you have it in coarse focus. Let's see, 8, 9, where's 10? 10 is the light switch, which turns on the lamp or turns off the lamp. 11 is the rheostat, which turns on how bright the light is or how dim the light is. And apparently in Australia, they don't use the term rheostat. And so the person who made this lab is from Australia, and he called it the light intensity dial. Either name is good. And then 12 is the lamp, which that actually doesn't quite look right. Let me see if I can move that down a little. And that one might need to move down a little too. About right there. Let's go ahead and save that. Hopefully that's saved. All right. All right. Any question about any of these? Parts of the microscope? All right. You need to know this table. The name of the 4x lens is a scanning lens, and I don't use the name. I typically use 4x. It has a total magnification of 40x. That is the magnification of the objective lens times the magnification of the ocular lens. And all of our microscopes at Clark College, at least in the microbiology lab, have an ocular lens of 10x. So the total magnification is 40x, 10x times 4x. Now, that's not the most powerful magnification you can get or the most expensive microscope. The most expensive microscope will have an ocular lens of 20x. And I've also seen an ocular lens like on a child's microscope that only magnifies 4 times. So the ocular lens can vary, but as far as I know, all of the ocular lenses at Clark College are 10x. And that's partly because we haven't put money into buying the most expensive microscopes. The depth of field for the 4x lens, it's deep, meaning that when you're looking at an object, can you see the cup here? Anyone? It's in front of my face, so you should be able to see
Yeah.
the top of the object and the bottom of the object when you're focusing on the object, because its depth of field is deep. And the field of view is large with this lens, meaning you can see the largest amount of the slide under the 4x lens. So, I don't know, this is the slide. With the 4x lens, you can see this amount of the slide because it's a large field of view. In some comments, the 4x lens is the easiest to use. For the low power lens, which is the 10x power objective lens, its total magnification is 100x, 10 times the objective lens. Its depth of field is moderate, so when you focus in on an object, you can see the top and about halfway down. You cannot see clearly the bottom of the object. If you see the bottom of the object, it'll be blurry or out of focus. And that's because its depth of field is smaller than the 4x lens. The field of view is also moderate or smaller than if the field of view of the 4x lens was this big, the field of view of the 10x lens will be this big. For the high power lens, also called the 40x lens or 40x objective, its total magnification is 400x. Its depth of field is small. So if you're looking at the object, if you can focus in on the top of the object, you can only focus in on, I don't know, maybe the object down to about here. And that's because it has a smaller depth of field than the 10x lens or the 40x lens. The field of view is also smaller. And if the 40x lens has a field of view, the 4x lens has a field of view that's this size, and the 10x lens has a field of view this size, then the 40x lens will be a field of view something like that size. So it's smaller than the other two. The oil immersion lens, also called the 100x lens, because it has a magnification of 100 times. Total magnification is 1,000 times or 10 times the 100x power. Its depth of field is very narrow. essentially you're only seeing a plane through the specimen. So if you're focusing in on the top of the specimen, you will see clearly only the top of the specimen. Even a little ways down, the object will look blurry. And that means its depth of field is the narrowest. And then the field of view is the smallest. It'll be a very small field of view, essentially close to a pinprick. So the oil immersion lens is the hardest to use because it has the smallest field of view and the narrowest depth of field. You have to be focused on it precisely, or you're not going to be seeing the specimen at least clearly. And the field of view, you also have to have the specimen directly under the lens because you don't have much of the field of view. You're not seeing very much of the slide. And then the 4X lens, you're seeing the largest portion of the slide, so you're likely to find the specimen in your field of view. And it has the greatest depth of field, so wherever you're focusing on the object, you can see the object clearly as long as you have it in focus. Any question about any of this? This table you should memorize, by the way. So the total magnification is the magnification of the objective lens times the magnification of the ocular lens. And all of our microscopes have a 10x ocular lens. When you view an image under the microscope, it's more than just magnified. For example, the letter E is magnified, inverted, and reversed. So the letter E will look like that under the microscope. Magnified, inverted, and reversed. Any question about any of that? All right. In this lab, it says the iris diaphragm is the most important part of the microscope for determining how much light gets into the specimen. And there's actually another one which I would agree is very important, and that's the rheostat. But both of them are important, and so if you answer that question, either answer will be correct. But more importantly, the iris diaphragm affects the contrast of the specimen against the background of the field of view. Now, the background, for most of the time, it'll be the glass slide, which will be transparent. And generally, you want the greatest contrast between the specimen and the slide. And how you get the greatest contrast is you set the iris diaphragm to the size of your field of view, meaning you change the cone of light coming up through the specimen to be the size of your field of view. And then you'll get cooler illumination where you'll have the greatest resolution and the greatest contrast between your specimen and the background of the slide. Any question about any of that? And how you do that is you just change the shutter of the iris diaphragm so that it gives a cone of light equal to your field of view. That means when you're working with the 4X lens, you should have the iris diaphragm open almost all the way. And when you move up in power with the objective lenses, you should start shutting down your iris diaphragm. Any question about any of that? So with the 4X lens, if the field of view is this big, your cone of light should be this big, so you shut down the iris diaphragm to give you the cone of light that big, and then you'll get color illumination. And then with the 10X lens, your field of view is smaller, so you shut down the iris diaphragm to be equal to the size of your field of view. And the same with the 40X lens and the 100X lens. And with especially the 100X lens, you should shut down the cone of light so it's equal to your field of view to get cooler illumination to see the object with the best resolution and the best contrast. Any question about any of that? All right. Tips for focusing. When you're first using the microscope, you should use the scanning objective, the 4X objective in place. Why? Because it's the easiest to use. Wherever the specimen is on the slide, you have the largest field of view, so it's most likely to be in the field of view of the 4X lens. And then also, when you're focusing on the object with the 4X lens, you have the biggest depth of field that you can focus on and still see the object. Any question about any of that? And then you use the coarse focusing adjustment knob to slowly raise the stage and bring the macroscopic object into macroscopic focus. Once you have it in macroscopic focus, you then adjust the focus with the fine focusing knob. Getting it into fine focus with the fine focusing knob. Once it is in fine focus, you should never go back to using the coarse focusing knob because our lenses are parafocal. Can you guys see these pencils and pen, or do I need to turn on the light? Anyone?
If it's right in front of your face, we can see it.
Okay,
Yeah.
great. All right. So our lenses are parafocal. That means when you're using one lens and then you switch to another lens, the other lens should have the object in focus. And if you need to focus, you should only use the fine focus. Because if you use the coarse focusing on the other lens, you've destroyed the parafocusing. And what you should do is go back to your 4X lens and then use the coarse focus to bring the specimen into coarse focus, and then use the fine focus to bring the specimen into fine focus, and then move the next higher power lens into place. And it should be in focus. If you need to focus at all, you only need to use the fine focus a little bit. So if ever you make a mistake and you use the coarse focus, you should actually go back and switch the lens to the 4X lens because it'll be easier to focus with the 4X lens. And that's because our microscope lenses are parafocal, meaning the image should stay in rough focus whichever objective lens you use. You just need to use the fine focus a little bit to bring them into fine focus. Now, before you switch from the 4X lens to the 10X lens, you should center the object that you're viewing in the center of your field of view. Why you do that? Well, let's say this is our slide. I don't know if you can see that. And our field of view is this much, and our object is over here. You then go to the 10X lens, and its field of view will be smaller. You now no longer have the object that you were viewing under the 4X lens in the field of view. So you want to move the object in the center of your field of view each time you switch to a higher objective lens. Any question about any of that? And that's just to bring the object inside the field of view when then you switch the objective lens and you have a smaller field of view. Okay, because the microscope is parafocal, you only should use the fine focusing knob, and then you repeat step 9 for each next higher powered objective, meaning once we have it focused, fine focused, and in the center of your field of view for the 4X lens, you then move to the 10X lens, fine focus, move it to the center of your field of view, and then you can switch to the 40x lens, then find focus. If you need the 100x lens, you then switch the object that you're viewing to the center of your field of view, and then switch to the 100x lens. But the 100x lens has a important extra step, and that is to work, the 100x lens has to have a drop of oil. If you don't use oil with the 100x lens, it gives you no better magnification and clarity or resolution than the 40x lens. And the 40x lens is easier to use than the 100x lens because it has a larger field of view and a greater depth of field than the 100x lens. So if you're not going to use oil, you should only use the 40x lens. Why we use oil is because oil has the same refractive index as glass and allows more light to be gathered by the lens. This will increase the resolution and the clarity of the image. What happens is when the light leaves the glass and moves to the air, some of that light will be refracted at another angle and will not be captured by the lens of the objective lens. And so less light will get into the objective lens if you don't use oil. Oil has the same refractive index as glass, and that's why the light does not refract when it switched from glass to oil and then oil to the glass of the objective lens. No light will be refracted, and you'll lose less light, and so you'll gather more light, and that will improve the resolution and clarity of the image. Any question about why you use oil? And you have to use oil with the 100x lens. What you do when you're going to use the 100x lens and you have it in focus with the 40x lens, move the object to the center of the 40x field of view, and then you move the 40x lens halfway out or the 100x lens halfway in, and that should allow you to add a drop of oil. I don't know if you can see this. Just one drop on top of the slide. And then that 100x lens, when you move it over the slide, over where the specimen is you're trying to view, that slide should actually go through the oil and pick up the oil, meaning that 100x lens is close enough to the slide that it will pick up the oil. So there will be no air between the slide and the objective lens. Any question about any of that? We'll talk more about the basis of oil and its why it improves the resolution in a later lab. All right, once you've used oil, you need to remove the oil from the 100x oil immersion lens. Otherwise, the oil will be there and you'll have to see through it and will cause blurriness. But also the oil can dry on the lens. And if it dries through the lens, you really won't be able to use the microscope. At least not that lens of the microscope. So you need to clean the oil from the objective lens, which in this case will be the oil immersion lens, using only lens paper. Students only use lens paper in the microbiology lab. You could use lens cleaner, but generally, if a student has like a stubborn stain on their lens or a oil dried on their lens, they'll notify me, and then I'll get the lens cleaner and then remove it from the lens using lens cleaner and lens paper. And if the microscope needs further cleaning, the student can clean it with lens paper. So usually students only use lens paper. It is true you could use Q-tips or cotton swabs on the lenses as well. We usually don't use those on the lenses at least the objective lenses. You use them on the ocular lenses, but we don't usually clean the ocular lenses. And every time you use oil, you have to clean the lens with lens paper. You should check the 100x lens because obviously you used oil, so it should be there. You should also check the 40x lens because it's low enough that if you rotate the objectives around the slide, that 100x lens will go through the oil and pick up the oil and will have oil on it. So you should always check the 100x lens and the 40x lens when you're using oil. And then remove it with lens paper. You never use regular paper on the lens because regular paper has wood fibers in it. Lens paper is chemically treated to remove the wood fibers. And why do you think we do not have wood fibers in lens paper? What would wood fibers do to the lens?
Scratch it.
Scratch it. And you don't want that because that'll damage the lens. And lenses are the most expensive part of the microscope. And if you were to scratch the lens, you'll have to be using a scratched lens for the entire term because I'll guarantee you they will not repair it in the middle of the term. And it's questionable if they would even repair it after the term because obviously it will depend on how much money they have. Because usually the way to repair that is to just buy another lens. And that's the most expensive part of the microscope. So you only use lens paper on the lenses. You never use chem wipes. You never use paper. You never use paper towels. You never use your finger. Any question about that? Now, technically, you could clean it with cloth, but we don't have any cloth in the microbiology lab to clean the lenses with. And I think it has to be, well, I'm not sure. I think it can be any cloth, but like I said, we don't have any cloth to clean the lens in the microbiology lab. We only have lens paper. All right, activity 1 is getting the size of the field of view. Online students will not perform this activity with a microscope. Therefore, the table below has already been filled in for you. However, you will be expected to know the information contained in the table and how to use the formula in point 5 below to get the diameter of the field of view. And you could use this table using the diameter of the 4x lens, or you could just memorize this table, either one. So we filled in this table for you. If you were to come into a real microbiology lab, we would give you a ruler and then ask you to measure the field of view for each objective lens. For the 4x objective lens, the field of view is 4.5 millimeters. That's 4,500 micrometers. For the 10x lens, the field of view is 1.8 millimeters or 1,800 micrometers. For the 40x lens, the diameter of the field of view is 0.45 millimeters, and the diameter in micrometers is 450 micrometers. For the oil immersion lens, 100x lens, the diameter of the field of view is 0.18 millimeters or 180 micrometers. Now, for the students who actually had to measure this, very few of them would have gotten the correct size for the diameter of the field of view because the smallest unit on the ruler is 1 micrometer. And so they'd have to estimate for this one and for this one. And even with this one, most of the students would get that wrong. Most of them would say about 0.5, and it's actually is 0.45 millimeters. And then almost nobody would get that one right. 0.18 millimeters. But we give them the correct answer at the end. And I'm giving it to you guys now in this table. You should use this table to answer the questions in the worksheet, or you should memorize this table. And I guess you have to memorize either the diameter in millimeters, the diameter in micrometers, either one. You don't need both. And you can get this measurement here, assuming that you know that the field of view for the 4x lens is 4.5. You can make the measurement by saying the diameter of the field of view for the objective n. So let's say the 10x lens is n. So the diameter of the field of view of the 4x lens is 4.5 millimeters times the magnification of the scanning objective, that would be 10x, divided by the magnification of the objective, that's the magnification of the scanning objective, which is 4x. So that's 4 point, no, it's 4x, sorry. And the magnification of objective 10 is the 10x. So you take 4 divided by 10 times 4.5, and then that'll give you something like 1.8. That's how you use this table. Does anyone want me to do that again because I kept making mistakes? The scanning objective is the name of the 4x lens. Is that a yes?
Yes.
Yes.
All right, like I said, it's just easiest to memorize the table, but if you want to use the formula for the measurement of the field of view of the objective that you're testing, we're going to call it objective N, is equal to the diameter of the field of view of the 4x objective. So that's 4.5 millimeters times the magnification of the 4x lens. So that's 4x, because that's this magnification, divide by the magnification of objective N, which is 10x. And that'll give you 1.8 millimeters. Okay? That's how you use that formula. Why is it important to know the diameter of the field of view for the different objectives? Because it allows you to estimate the size of this specimen that you are observing. For example, if we are using the, let's say the 40x lens, and the specimen takes up half of the field of view, what is the size of the specimen? Can anyone guess? Because I'm not moving on until at least somebody guesses. You don't have to be right, but I want somebody to guess. So the field of view is 0.45 millimeters, and the specimen takes up half the field of view. So what is the estimate for the size of the specimen?
0.225.
Something like that. Yes, it's about half, 0.45 millimeters, or something like 0.225, something like that. Assuming I divided that correctly by 2. All right, good guess. All right, so activity 2 you are going to be doing, but you're not going to be actually doing this activity, but you will be using the virtual exercise in the laboratory exercise at the end of this document. And we expect that you will know and understand the material both in the virtual exercise and in the instructions here in activity 2. So you need to read through activity 2 and understand it. You're going to obtain a prepared slide, work through the tips for focusing, view the specimen starting with the scanning lens, moving up to the low power lens, the high power lens. Remember, whenever you move up to objective lens, you need to bring the specimen in the center of your field of view before going to the next higher power lens. Moving up to the 100x lens is a little special because you have to move the 40x lens half the way out, move the 100x lens half the way in, but not in 100% of the way. And that'll give you room to put in a drop of oil. You put 1 drop over the specimen where the slide is under the lamp or over the lamp. And then put the 100x lens into that drop of oil over the specimen. Use the fine focusing to focus. And then when you're all done viewing the specimen with the oil, you need to rotate the scanning 4x objective into position over the specimen. Remove the slide from the stage. You have to remove the oil from the slide, and the objective lens, 100x objective lens, will at least have oil on it. You only use lens paper on the objective lens. On the slide, you may use a paper towel or chem wipes, or you can use the lens paper. Once you've cleaned the oil off of the objective lens, you can then take the lens paper to remove the oil off the slide. Like I said, on the slide, we don't care. The slides are cheap. You can use whatever you want. We don't care if they get scratched. And then put the slide back in the proper tray. Any question about activity 2? All right, you'll be doing activity 2 in the virtual lab, but you need to understand the procedure. For activity 3, it's making a wet mount. If you've never made a wet mount, you should go through the wet mount. Online students are not going to be doing a wet mount, and you're not going to be tested over this procedure. But if you've never done a wet mount, you should know that you just put your specimen in a drop of water, or you can put pond water directly on the slide. And then take a look at your specimen under a drop of water. And a wet mount is important because it allows you to view the specimen while it is alive in its natural environment. Like when you're looking at something that's in pond water and you put a drop of pond water on the slide in the wet mount, you're looking at the organism while it's alive in its natural environment, which is pond water. When using the drop of water on the slide, you normally cover it with a cover slip. Because it has a cover slip, you should not go higher than the 40x objective lens. You should not use the oil objective lens because the oil objective lens is so low, it could bump into the cover slip and either scratch the oil immersion lens or break the cover slip, and we don't want either of those to happen. So don't use the 100x lens when making a wet mount if you have a cover slip on. And then when you're finished, you discard the cover slip in the cover slip container with bleach, the slides in the large bowl with bleach, meaning the container for slides. And then you're done making a wet mount. I went through that in case you never made a wet mount, you should know about that. And then the next one, storage protocol. Online students will not be handling a real microscope, but you're expected to know how to correctly store a microscope because you've taken microbiology. So you should lower the stage when you're all done, remove the slide, put the 4x lens over the place where the specimen was or over the lamp. If you use oil, you should remove oil from the 100x lens as well as check the oil on the 40x lens, because if you move it through that drop of oil, it will pick up oil. So you should move oil from the 100x lens, and if it gets on the 40x lens, you should remove it from the 40x lens. And only use lens paper to clean the lenses. You should then lower the light intensity, switch the light off, unplug the microscope, wrap the cord to the microscope either around the base neatly, or there's some a microscope which have a cord and holders in the microscope, wrap them around the holders for the cord. We don't do step 7 because I never have people change the turret. And then 8, use both hands to carry the microscope, meaning one hand to hold the arm of the microscope and the other to support the base of the microscope, and then carry the microscope with 2 hands. Our microscopes are heavy, so most people do use 2 hands, but you should use 2 hands so that you don't not drop the microscope. You have both hands on the microscope. And then place the microscope in the same cupboard you got it out of. They're actually numbered, so you just need to know the number or the position, and then put them in the way you got it. So if this is the front of the microscope and this is the back of the microscope, put it in so the back of the microscope is facing towards you and the front of the microscope is away from you. Any question about putting away the microscope? All right, you can know the terms of this lab. You can go through that on your own. The references you can skip. And then we have 2 videos for you to watch in this lab. General microscope focusing, so watch that video. And then using oil with the oil immersion lens or the 100x lens. We got a little clip on using oil. When you're all done with that, you can go through the microscope by using the virtual microscope. This will allow you to use a microscope online. This will take a little while to download. Yeah, that's pretty good. Faster than the 230 lab. Still hasn't loaded all the way. Let's let it load all the way. Once you see the microscope, you know it's loaded all the way. And we're going to take a look at Explore. You can take a look at Guide, Learn, Test, Options if you wish. But for this lab, you need to use the Explore. And the question mark tells you what to click on. So we're going to choose a slide. Let's go with the plant slides. The onion root tip. And there we see the specimen with the 4x lens. It's obviously blurry. Let's change the coarse focusing till it gets basically a coarse focus. Let's use now the fine focusing. Move the specimen to the center of the field of view, which it pretty much is. And then go to the 10x lens. Once again, it should be in parafocal vision, and it is. So we don't use the coarse focusing now, and we only use the fine focusing. Let's get it finely focused best we can. I'm not seeing what I want to view, so let's go ahead and move up to the 40x lens. And let me get it in fine focus now. Let me look around for what I'm looking for. Oh, there it is. There's a cell going through mitosis. Let's move it to the center of the field of view. Finally focus it. Really about there. And then go up to the 100x lens. And you'll note that it says add immersion oil. The question mark is where you click. So we click there. We add a drop of oil. And then we move the 100x oil immersion lens into place through the oil. And now we need to fine focus. Going to increase the light a little bit here too. I'm not seeing what I was focusing in on. Let's see if I can find it. Oh, there it is there. There's the slide with going through mitosis. Any questions on how to use the microscope, or at least the virtual microscope? All right, let's remove the slide. So click there. And it says you need to use lens paper to remove the oil from the lens. Remember, you need to check the 100x lens because it obviously has oil on it. And you should check the 40x lens. Then we click here to get the lens paper. That's a tabulated lens paper, by the way. Rip off a piece, clean the oil from the lens. And then you notice they put the slide over here. And then change the microscope So the 4x lens is in place, meaning they got rid of the 100x lens. And then for the worksheet, you'll need to take a look at the animal slides, specifically the spider leg slide, to answer one of the questions. And you can, of course, focus that and then go through that one. I'm not going to go through that one, but you guys can do that in the virtual lab. All right, any question about any of that? If not, that's the virtual lab. And there's the link for it here. This is in the lab module, which you probably don't have. But if you go to the worksheet, it will have each of these 3 links. Come on. There's the worksheet. So there's the first link to the movie on general microscope focusing. There's the link to putting oil on the microscope. So watch those 2 videos. There's the link for doing the virtual microscope. You need to do that to answer one of the questions in the lab. And then we have a link for practicing with the microscope. And I've actually got 3 links in the lesson. I think it's week 3, lecture 3. 3 links here. If you click on this, let me open it in a new slide here, new tab. Oop, that's a new window. And that actually is working, but it's not working well. What you want to do is click on the link here, and then it'll open it outside of Canvas, which is what it really wants to do. And I'm surprised, to tell you the truth. Why did that go there? I'm surprised that even works, because it used to not work. But the other one, I don't think it works. Let me try that. Did that work? Oh, there it is. It just took a long, long time to go for some reason. So that one is not working. What you need to do is click on this link here to get it to work outside of Canvas. I don't know what's going on there, but there it's going there for this quiz here. And it says start now. Be very careful when you're coming here, because you can download things you don't want on your computer. So start now to start the metric quiz here. And then question 1, a kilogram is about the same as a pair of running shoes, a dollar bill, a feather, a truck. And a kilogram is a weight. Well, it's obviously more than a dollar bill and a feather. It's less than a truck. So I'm going to guess a pair of running shoes. If you get the correct answer, it'll show in green. And the metric base units include yard, liter, and pound, meter, liter, and gram, yard, gallon, and pound, meter, gallon, and gram. The incorrect answer is meter, gallon, and gram. We're going to submit that. If you submit a wrong answer, it will give you the answer in red, and it'll tell you what the correct answer is. And unfortunately, you cannot get back to this question to get another try unless you start the whole quiz over again. And the other question is, let me get to that right here. This is still opening in Canvas. Let's go here. Select the base unit of the metric system: liter, meter, gram, kilogram, kilometer. Oh, the base unit, the metric system for length is meter. Oh, I didn't know it did the sound there. Let me turn that down a little. Come on. If it shows you in green, you got the correct answer. It tells you correct, well done as well. And then move down. Be careful of the links here. Make sure you stay on the quiz. Like this will download something. I'm not sure what that is. Just be careful of what you click on here. And then select the base unit of the metric system for volume. I'm going to get the wrong answer here. We're going to say the meter. and it's actually a liter. But I want to show you, if you put the wrong answer here, it's red, incorrect, keep practicing. And it's showing you the answer, so you can't go and change your answer. But you can do the test again. Select the base unit of the metric system for mass. It's going to be gram. Don't click that because you'll start to download something. We've already started the test here. So what is the prefix for 0.01? Anyone want to guess? I'll tell you in the last lab, somebody guessed wrong. So just guess. The worst you'll be is wrong. What's the prefix for 0.01? Is it a kilo, a centi, a micro, a milli, or a hecto?
A milli?
That's what somebody else guessed, but no, a milli is 1 to 1,000. That's 1 to 100. So the correct answer is centi. But let me give you a compliment for guessing, okay? So thank you for guessing. And the correct answer is centi. All right, that's the quiz. The practice, this is us, the quiz for practicing on the metric system. You do need to know the metric system. For science and medicine, you will be tested on it. So probably a good idea to practice with the quiz. And it'll help you also for this lab that we're doing. All right, let's go on to the questions of the worksheet. We have the same video links and the same virtual microscope link, the same practice microscope, but actually you should find the 3 because you can go through 3 quizzes. This one only gives you 1 quiz. And then 4A, when focusing a specimen, you should always start with which objective lens? 4B, when using the low power, high power, and oil objective lenses, only which focusing adjustment knob should be used? The coarse focus or the fine focusing adjustment knob? 4C, the type of microscope used in the lab is what type of a microscope? And don't tell me Nikon microscope or what's the other name? Forgot the other name of a microscope because that's the name of a company that makes microscopes. I want to know the type of a microscope. And here's a hint. It has to be 2 words or it's wrong. Okay? And it's someplace in the lab module if you want to look it up, if you don't know the answer. And then 4D, you should carry the microscope by holding on to what part of the microscope with one hand and by supporting what part of the microscope with the other hand. 4E, the objectives are attached to this part of the microscope, which can be rotated to click the different objective lenses into place. So name that part of the microscope. 4F, if a microscope had an ocular lens of 10x and a high power objective of 45x, what would be the microscope's total magnification? So give me the answer there. And you could do this by going to AI, but let me warn you that in the future, in a quiz, you will not be allowed to use AI. So you should try and answer all of the questions in this worksheet on your own. And then you can use AI to verify your answer. Okay? All right. 4G. When the stage is moved left, the image moved through the ocular moves in what direction? When the stage is moved forward, the image moved through the oculars moves in which direction? 4H, the objective lens, which objective lens provides the largest FOV, FOV standing for field of view? And 4I, which objective lens has the smallest field of view? 4J, of the methods for light adjustment, which is the most important on the microscope? The lab module does state it. However, I will agree that there are 2 parts of the microscope which are important for determining the amount of light coming through the onto the specimen of the microscope. So if you name either two, I'll give you credit. And then 4K, how large is the field of view when using the high power objective lens? You need to answer in millimeters or micrometers. You can't simply just say small. Okay? So you must give an answer in millimeters or micrometers, and there's a table in the lab module which tells you the answer. All right. For question 4L, how many hairs are on the animal slide when viewing the spider leg under the 100x objective without moving the slide from side to side? And you need to do this by using the virtual microscope. For 2, suppose you have a typical bacterial cell that is 2 micrometers in diameter, and the circle below, which represents the field of view, when viewed with the immersion objective, state how many cells can fit across the circle, meaning the field of view of the oil immersion lens. You need to show your calculations in your answer for full credit. Any question about any of that? All right, so that's the lab. I will be here at least until 8 o'clock, maybe 8:15 until the last student logs out. If you have a question, I am here to help you with the lab. So get started on the lab. And like I said, I'll be here until at least 8 o'clock, maybe 8:15, or until the last student logs out. Any questions? All right, get started on the lab. Oh, let's stop the recording.
Must have missed something. Are they,
Quizzes, yeah.
do we need to do those like for extra help? Are we going to be graded on these?
You're going to have quiz questions on similar material,
Okay.
but if you're very strong on the metric system and you don't think you need to review it, you can skip the metric quizzes.
Okay.
Okay. But if you're weak on the metric quizzes, you should take the quizzes because it'll strengthen your knowledge of the metric system. I mean, even if you get a wrong answer, it'll tell you what the correct answer is, and you know that answer was wrong.
Okay, thank you.
All right. Start recording. Okay, what's your question?
So I'm reading through question 2. And I feel a little bit confused by this. Are we supposed to be using the formula for this? I'm assuming so, based on showing your calculations in the answer.
You can use the formula, but you could also just use the table, meaning you use the formula to get the answer in the tables.
Okay.
So either one.
Okay, great. Thank you.
All right.